Hello students, this is Professor TK the Chemist, and today we're going to go over electron configuration. So this is part of a series of my workbook that I have provided in terms of writing out electronic configurations. And so if you would like a copy of this video, or excuse me, if you would like a copy of this workbook, make sure you comment below that you want the workbook and I will get it to you. Let's get into our video today on some easy tips on how to write electronic configuration. Tip number one, you want to learn the electron configuration song. Now, I say it's a song, but it's more like a catchy phrase. 1s2, 2s2, 2p, 3s, and so forth. So whenever you're doing these, you want to keep the order in mind. It starts off with the first energy level, and then it exceeds that, all the way to the seventh energy level. But there are some other sub-levels you need to know in between, which brings me to number two. Use the periodic table as a roadmap. So in other words, whenever you look at the S block, P block, D block, and F block, they have a set number of maximum amounts of electrons you can hold. So when you look at the S block, which are parts of group 1 and 2, plus helium, you know that the S block can contain up to 2 electrons. When you look at the P block, which consists of groups 13 through 18, which is found on the right side of the periodic table, those have a maximum of 6 electrons. When we get to the D block, those are your transition metals. They're located in the middle of the periodic table, and they can hold a maximum of 10. Now, when you get to the F block, those are what we call the lanthanide and actinide series. Those are the two rows below the main table, and those are the two parts of the periodic table that were extracted from the periodic table to shorten the chart. Now, here's the thing though. Each period or row in the periodic table tells you the energy level of the orbitals you are filling. So for instance, period 2 equals 2s and 2p. Period 3 would equals 3s and 3p. Now, I kind of already stated this in the previous section where I said to remember the 2, 6, 10, 14 rule for maximum electrons. Each type of orbital can hold a specific number of electrons. The s orbital can hold a maximum of 2 electrons. P orbital can hold a maximum of 6 electrons. D can hold 10. F can hold up to 14. Use this rule to check that you are not exceeding the orbital capacity when filling those electrons. Now, tip number 4 talks about Aufbau Principle, meaning low to high. Electrons always fill the lowest energy orbitals first before moving to higher ones. This is called the Aufbau Principle. Imagine you're stacking books on a shelf from the bottom up. You need to fill the lower shelves before moving up to the higher ones. So that's an example that you can use to remember rule number 4. Rule number 5, or tip number 5, don't forget about Hund's rule. When filling a set of orbitals like P, D, or F, you want to remember that electrons will fill each orbital singly before pairing up. This is Hund's rule, often referred to as the school bus rule. Students, hence the electrons, prefer to sit alone in seats before sitting with someone else. So it's almost like this in terms of the drawing of the arrows up and down, just to kind of give you all something to think about. Up and down, up and down. So when you look at the seats, for instance, 2s, okay, if we were looking at the 2s section right here, and then the 2p section, you want to fill all of them up before you insert the additional pairs. Just an example. Now, when you look at number 6, know the Pauli exclusion principle. Well, here's the thing. Each orbital can hold 2 electrons at most, and those electrons must have opposite spins. This is Pauli's exclusion principle. So when you're filling orbitals, make sure to draw one arrow pointing up and one arrow pointing down. So basically 5 and 6, pretty much are relatable that go together. Tip number 7, this is what I said earlier. You want to remember the order of orbitals for electronic configuration. So when you're writing out the electronic configuration, you want to write down the orbitals in increasing energy levels. So if you noticed here, let me show you, let me point this out so you can see this, okay? You've got 1s, 2s, 2p, 3s, 3p, 3d. There is a certain order that you would go by. And that order is right here at statement number 2, where you're going to start off with 1s, then go to 2s, then 2p, then 3s, then 3p, 4s, 3d, 4p, and so forth. If you remember this order, you put them on note cards. This is going to help you become very successful in writing out the electronic configuration for different elements. So you want to make sure that you keep this particular guide in mind in terms of the order that you go to filling up your electronic configuration, for your given element. Check it out, check it out. Watch out. You notice I have a caution sign right there in the middle. There are exceptions to the rule when it comes to your transition metals. These are kind of tricky because they are part of the D blocks. Now, elements like chromium and copper prefer a half-filled or a fully filled D orbital to gain stability. So if you look at chromium, for instance, right here on your screen, okay, you see chromium right here. Notice that, and I made the abbreviation version, the noble gas configuration. Notice how you see argon in brackets, but then the latter part is 4s1 3d5. You would write that for chromium instead of writing 4s2 3d4 because of the stability factor. So again, you want to remember that there are two that are exceptionals to the rules, okay? Exceptions, rather, to the rules, chromium and copper. Memorize these few exceptions early so you can avoid what? Confusion later. Here is another tip. Check your work with the periodic table. If you're unsure about your configuration, you can always check the elements group number. So for instance, elements in groups 1 and 2 ends in the s orbital. Elements in groups 13 through 18 end in the p orbital. Your transition metals will end in the d orbital, whereas your lanthanide and actinide series of elements will end in the f orbital. So for instance, if your configuration for chlorine, which has an atomic number of 17, ends in 3p5, right here for chlorine, this tells you that you're on the right track because chlorine is in group 17, which means it's part of the halogen groups, but that also responds to the P5 configuration. If you look on your periodic table, find chlorine. Find what group it is located in. Okay, now that you found that, you can now refer to chlorine being in group 15. It's also in the 5th block of that P. Okay, so that's how you're able to track out what you've got. So again, look at your periodic table, find chlorine. Okay, you got it? It's in group 17, right? Yep, that tells you that you're going to have 7 valence electrons on that last orbital of your electronic configuration. And also, the last thing you would write is 3p5. Now, in case you need to see this visual, because I'm all about being a visual person in terms of writing it out, here is what we're talking about here. When you write your configuration for chlorine, you've got 1s2, 2s2, 2p6, 3s2, 3p5. Now, on this last energy level right here, see that? The third energy level for chlorine has 7 valence electrons because it is in group 17. See, there are so many tricks and patterns that you can remember in allowing you to be successful when it comes to writing out electronic configurations. And finally, practice makes perfect. Electronic configuration can feel like a puzzle at first, but the more you practice, the easier it becomes. So make sure you are doing what? Writing out the configurations for elements in the first 3 periods. You can practice using the diagonal rule. You can also challenge yourself to practice writing the D block elements and exceptions, those that we talked about previously. Now, I know you're ready to get into some examples, right? But before we do, let me give you some bonus tips. Here's your bonus tip. When you're dealing with ions, you want to add electrons for negative ions, meaning those anions, and you're going to subtract electrons for those positive ions, meaning your cations. Always adjust the electronic configuration accordingly. So I'm going to say this again. When you're dealing with ions, okay, ions, can y'all say ions? Good, there you go. You're going to add electrons for negative ions. So those that are negatively charged, you're going to add that number. And if you have a positively charged cation, you're going to subtract those electrons. And I'm going to show you an example right now. So for instance, if you have sodium, you see how sodium has a positive one charge, right? It has one less electron than the neutral sodium. So in other words, if you write out the configuration for a sodium atom, let me show you what I mean by that. Sodium, okay, according to your periodic table, has 11 electrons, the sodium atom. So if I write out the electron configuration, it's going to be 1s2, 2s2, 2p6, 3s1. Now, when you add up those superscripts, 2 plus 2 plus 6 gives us 10, plus 1 gives us 11. Now, in this example right here, where they told you there was sodium with a plus 1 charge, the sodium ion, you know what you're going to do? You're going to remove this 3s1 portion of your configuration because it's losing an electron because of that positively charged ion. So this is what you would end up writing as a result. You would end up saying, okay, well, it's going to be 10 electrons. That means you're going to have 1s2, 2s2, 2p6, and that's it. The same thing occurs for chlorine. When you have chlorine and it has a -1 charge, you're going to actually add an additional electron. Because it's negatively charged, you're going to add one. And finally, these are some things you want to remember before you complete each problem. Be sure to know these things. Number one, how many electrons does that element have? Number two, what block is the element located in? S, P, D, or F? And finally, in number three, what energy level is the element located in? Remember, there are 7 periods and they go across the periodic table. And by doing those last 2 parts of this statement right here, this will assure you, and writing down the last part of that electronic configuration. Now, in the next video, we're going to show you several examples of writing out electronic configurations. Stay tuned. I hope this video has been very helpful for you. I just wanted to give you all some quick tips that you can use when it comes to trying to determine the electronic configuration format. It doesn't have to be difficult at all. So in the next videos, I'm going to give you several examples. Stay tuned. Have a good one.